All right, page 4 of 1167. We talked about the scale on the normal curve, normal distribution. We talked about the z-score on the standard normal distribution. And now we want to talk about the cumulative area or the shaded area or the probability that a certain data point would be in that area. So when we were talking about that, we kind of, let me draw a picture here. So we had this kind of thing going on, and we were talking about this shaded area here. And when we had a value, that would be its x on the x scale, all right? There's not really a shaded value like under this line, okay? So they talk about it as being within this shaded area or within in this shaded area over here. So when they talk about a z-score or an x-score being above this, they're going to put the greater than symbol if it's in symbols. I went through Alex and I didn't see a lot of symbols, but this points to the right, so this is a right to the right. If it points the other way, it's to the left, or if it's a lower number to the left. So we want to kind of understand what's to the left and what's to the right in the shaded area, okay? There is Alex does have an appendix area that has this, and this is available in the questions, but I'm not really happy with the table that it has for the distributions. I think you're even better off like Googling for a better table. I put at the end of this lesson are the tables that I use. Got them from somewhere else. Been using them a long time that way, and I don't even remember at this point where they're from. But the one that Alex gives you, you have to think about the other sides. I think they thought it was being simple, but I mean, if you can use them, great. My brain just doesn't work that way. So you might want to print out the last 2 pages of this lesson that have my forms on it. I'm going to use them to do this. I know it seems a little unfair not to use the ones that come with it, but honestly, I just don't do very well with them. I think they're harder. So I'm going to use mine for this video, but feel free to use any of them. Any of these will work in Alex for your answer. Just Alex is odd that it wants everything rounded to 3 decimal places. So if you, like if I'm going to use these, they all have 4 decimal places. So I'm going to round my areas to 3 decimal places, even for the percentages, okay? And use standard rounding rules. So if you have, if I'm reading this and there's like a 2, 1, 5, 3, and I need to round this to 3 decimals or a percent, it'd be 0.215 or 21.5%, because that's just a 3. We're not going to round that up to a 6. So use 3 decimals, because when you use their charts in Appendix A, they're all in 3 digits, okay? But it'll still work out if you use anything else. So I have the positive and negatives at the end of this thing, so I'm going to use those. All right. So to find the area under the standard normal curve to the left of the z value, find the value and I'm just going to show you how. Let's look at this over here. Find the area to the left of z. This is all, Alex usually doesn't have this. They're just going to say to the left of this. So what does that look like? Real quick. I just want to, just a quick sketch always helps me. If this is a z scale, then 1.32 is up here somewhere. And if they say to the left, find the area to the left, that's here. So that's all of this. This looks like a pretty big area. In fact, from here over, what was it? 0.5, half of it, because the whole thing's 1. So my answer better be a bigger number than 0.5. Okay. So because this is a positive number, I'm going to go to the positive z-score table and look for my 1.32, a z of 1.32. Here's my z's, and these are the first 2 digits. So 1.32. Okay, 2 digits over here, third digit over here. Where does it meet? Right here at 8888. Let me double check that. 1.32. 1.32. Oh, okay. So be careful when you're going across. So that's why these blue things are here. So right here is 0.2. 0.9066. So right here, this whole entire shaded area is 0.9066, or 90 point, here, let's round them for Alex here. This is 66, so this would be 0.907, or 90.7% for your Alex homework. Okay. So 90 seems a lot, but maybe this curve looks like this. So if 0 is here, then 1 something is kind of like here, and all this shaded this way. So it kind of makes sense that that is like 90% of the cumulative area, okay, out of 100%. All right, but what if it says to the right? So I do this so I can keep straight my negatives. This is negative 0.67. And then it says to the right of that. So to the right of that, it's this way. So that's all of this. So again, this number is more than 0.5. I need all of this here. But since this is a negative number, I want to go to the negative scores, and I'm looking for the negative 0.67. So look at the negatives start big, come down, 0, 6, and then I need to find 7. So 7 is here, come down for 7 till we find the 0.6, which is in white, which is 2514. And what they're giving you is that this is 2514, because these charts say these are the areas to the left. So this particular table that I'm using only gives you to the left. Most tables only give you to the left. Alex gives you to the left here. And you have to to find this, you'd have to find to the right to get here, because this is the same as that. And I know that's kind of super confusing, but Alex's charts only give you here, no matter what, whether it's to the right, to the left, or whatever. It's to the left of the Z to 0. So if you're looking to the left of this Z to the end, that would be the same as the right up to here. So I thought that was really confusing. But anyway, let's take a moment. If they only give you to the left, that's here. And the whole thing is 1. So subtract the given area from 1. So 1 minus 0.2514 is your 0.7 0.1486 rounded to 3 decimals is that. So if this ends up being off one number or the other and you need me to go in and give you credit for something, just send me an email, okay? I've used different online masks for this. I've used web Cengage product. I've used different ones, and it just never seems to have every answer right on the nose. So if you're in the ballpark here and you're off one, just let me know and I can give you credit for that. Every teacher does it their own way. I just, we just need to do the best we can. Okay. All right. So what about something between? So if 0 is here, then 1.45 is here, and 2.32 is here. So between would be here. So what I'm choosing to do is get this to the left from 145. That is a positive 145. Positive 145 is 9265. 9265. And then I'm going to get this one that goes all the way to the left, 232, 232 is 9898. So how do I find this right here? Well, this is the 9898 minus 9265. Hang on just a second. Which is apparently 0.0631. I don't spend a lot of time putting this 0 here. It doesn't matter if you do or you don't. But that's there. So only 6.3%, or yeah, 0.063. Drop that 1 if you're putting in an Alex for that shaded space. Okay. All right. 2 tails, each end only. What makes this different is that for the probability, you have to combine the numbers. So this one says to the left of -1, well, it's probably not all the way down there, but these are sketches. Nobody's going to grade you on how accurate these are. And 2.32. So I need this added to this. Basically, the probabilities of being in both extreme ends. Okay, so that's not going to be a lot. So let's see, -145. I need this way. That is a negative, so I'm going to get the negative score out. 1.45. 0.0735. All right, and then if I looked up 2.23 here and got this whole way is 0.9898. So to get this way, it's 1 minus 0.9898. 1 minus 0.9898 is 0.0102. And then because it's a 2 tail, we want to add 0.0735. And get 0.0837, which rounds to 0.084 for this probability. Okay, or area, cumulative area, probability, percent chance of something falling in these shaded areas. Whoops, and the whole thing was too low. I apologize. Here's my, sorry about that. Here's mine to the left, and here's mine to the right. This one I looked up on the negative table to the left. This one was looked up on the positive table all the way over. So this way is 1 minus that, gives you this. And then for a two-tail, you have to add them together and then round to 3 decimals if you're in Alex.